Are they all the same?
All right, so let's look at these four graphs. So in these graphs, I'm going to kind of change it a little bit to make it seem less confusing because the notation is kind of weird. So a graph has, like, generally graphs have like symmetry or at least a line, but in the graphs that are up here, the y-axis is kind of cutting the graph in half. So it has a left side and a right side. Instead of saying as x approaches infinity, we're going to look at it as being on the left side of the graph versus being on the right side of the graph. So graph has a left and a right. We're going to think of a graph as being on the left and the right. What's happening on the left side versus what's happening on the right side. So there are four options up here, and there's only four different things that could happen within behavior. That's because the degree could be odd, or a degree could be even. There's only two types of numbers. It's either odd or even. So if it's odd, it has one shape. If it's even, it has a different shape. Every odd power graph has the same end behavior, whether it's x cubed, x to the 7th, x to the 25th. So the end behavior is exactly the same.
Pardon the interruption. The holiday breakfast scheduled for tomorrow has been postponed until January 5th. Let me repeat that. The holiday breakfast scheduled for tomorrow is rescheduled for January 5th. Thank you.
Okay, so I have two examples up here. It doesn't necessarily mean that those examples are this, but just for you to get to think of like some kind of number. So if my degree is odd, so 2x cubed, the degree is odd, but the leading coefficient is positive, so that's why I have a positive 2. When you look at the graph, it's going to look something like this. Every odd graph will have that same type of shape. So when we're describing the left side of the graph, I want you to describe where the left side goes. Where does it end? So this part's pointed down, but what does it mean if it's pointed down? Where's it going? Negative infinity. So on the left side, it goes down to negative infinity. So that's what we're going to think about when we talk about the end behavior. So that means the right side does the opposite, because when it's odd, it kind of like splits. One side does one thing, the other side does the other thing. So on the right side, the end of the graph goes to positive infinity, where we would say that it goes up to that value. So when it's odd and negative, the left side goes down, the right side goes up. Oh, thanks. Thank you. So if we look at the opposite, if I have negative 2x cubed, it should be the opposite of what we have. The graph should be flipped. So what was going up now flips and goes down. So the graph essentially is now the opposite of what we started with. So again, think of it as the left side versus the right side of the graph. So now the left side of my graph goes up, and the right side of my graph goes down. So any odd power, if it was negative 2x to the 15th, the left side is still going to go up, the right side is still going to go down. So odd power and the fact that it's negative is what determines where the graph goes or the end behavior. The two below are when it would be even. So even and positive versus even and negative. Every parabola that we graphed is something x squared. X squared, remember the parabola, like both of them went up, or both sides of the parabola went down. Either opened up or it opened down. It didn't split. And that's what happens with even graphs. So even graphs, both sides do the same thing. So they either both go up or they both go down. So positive example here, we could have like 4x to the 4th versus negative 4x to the 4th. And again, think of it as the right side versus the left side. So because it's even, both of them are going up. This looks like a little W. So both would be going up to positive infinity. whether you're on the left or the right, because it is even and it's a positive number in front. So if it's even and has a negative number, it looks like an M. So the left side versus the right side, well, the left side is now going down, and the right side is also going down. So I know right now end behavior doesn't seem like it does a lot, but once we start looking at equations, you can at least know the shape of a graph based off of where it should end. Question?
On the even positive, do you mean turn positive?
So there's one other word down below, and then we'll look at a graph on the top of the next page. If something is critical, what does that usually mean? It's important. So critical points are going to be important points of our graph. We will go into more detail with that tomorrow and Friday. But generally, they're like the x and the y intercepts, maybe the highest and the lowest point, but they're the important details of the graph that will be used to help graph. So after you're done with that, if you'll flip it over to the last page of the section. We're going to see if we can try and graph one of these functions by making a table of values or t-chart and plotting the corresponding points. And then it says connect the points with a smooth curve, so no jagged, edgy lines, and check the end behavior. So I want us to do the check the end behavior part first, just so you get an idea as to how you're supposed to think about end behavior. So to determine end behavior, you need to get the degree of the polynomial. So in this case, what's the degree of the polynomial? Lexi? 3. So it's a 3, and let's say 3 is even or odd? Odd. And the coefficient in front of it is -1. So it's odd and it's negative. So think about the left and the right side. So Lexi, if it's odd and negative, the left side of the graph does what? Yeah, so the left side goes up and the right side goes down. So odd and negative, it kind of splits. So the left side is up, the right side is going down. So when we graph it, we should use or can use that to kind of check our work. So when we're graphing it, you'll know that you're plugging it into the calculator correctly based off of what we have already for the end behavior. So 5 points that we usually pick, -2, -1, 0, 1, 2. You have your calculator out. We're going to plug this into the actual, like not the graphing screen, but I want you to just kind of get used to doing this manually. It's really important when you're plugging numbers into the calculator that any value you're using for x goes into parentheses when you're dealing with squaring and cubing and taking things to the large powers. So it says -x cubed. Well, the negative is separate from the x. So the negative's outside. I'm plugging a -2 in it and I'm cubing it. And then we're plugging a -2 in and squaring it. And then taking 3 times -2 and then the -3. So when you put it in your calculator, you can put it in one entire swipe. Like it doesn't have to be separate, enter, enter, enter. Put it in one time, but make sure you're putting the parentheses in the calculator. So it tells the calculator order of operations. It lets the calculator know that the quantity needs to be squared and that all of it should be squared. So when you do that, you should get the number 3.
I'm not negative, darn. I don't know.
So check to make sure how you have it in there. You should get a +3.
I got a negative.
And it needs to start up high because the end behavior is supposed to go up on the left. So that's good. That's a way to check yourself. When you plug in a -1, just because we're running out of time here, you should get a -4. You don't need to plug in a 0 because when you have a 0, it's going to be not 0. -3. Emily, question?
Whenever it's -2, 3, should the first point be over 1? Or
I was looking at those things, but I wasn't listening. Okay, I wasn't sure if it was kind of
No. Alright, so when you plug in a 1, you're going to get a 0. And then when you plug in a 2, you get a -1. So it looks kind of crazy. When you connect the dots, start with the first one you graphed. So we started with -2, 3, go all the way down, and then you have to curve to connect to the third point, up to the fourth point, curve back down to the last point. So like you're connecting the dots literally from the first point to the second point to the third point and so on. Domain and range, remember, are the y and the x values. In this case, it covers all of the x and all of the y. Tomorrow we'll do more graphing. Have an awesome day. Please make sure you're making T-charts for those 5 graphs at the end of your homework.
Okay.